Hello and welcome to Chapter 1, WAN Concepts. So today we're going to talk about the different types of WAN technologies that are out there and the definitions of the different types of devices and terminologies that you need to know when it comes to a WAN. So hopefully by the end of this chapter, you'll know what a WAN is and how it works and the different types of WAN connections that are out there. All right, so let's begin. When it comes to WAN technology, what is a WAN? A wide area network is the interconnection of two LANs that are in different geographic areas. So if you have one network on one end and another network that is far apart from each other, and you need to call a service provider, and the service provider will set up a router, for example, on your end, and will take your data and go through a WAN, either private or the public, the internet, and then going through those different types of, the switches and routing, and then finally it will get to you on the other end. This is really a cloud because we don't know exactly which path our data takes, either the internet or the private WAN. All right. So again, wide area network is the interconnection of two separate LANs that are in different geographic areas. All right. So please write this down. What is the purpose of the WANs? That's what you're going to be. Everything that I ask you to write down is what you're going to submit as proof as that you have seen this video, and it will be your homework for week 1. All right, the purpose of the WANs, there are point-to-point connections. You can actually set up a WAN to have as if you were directly connected to routers using a T1 line. A T1 line connection is when you have physical wires that are dedicated to you. No one else will use these wires if you go from, no one actually does that if you can go from New York to LA, and you can have physical wires connecting from one hop all the way to LA, from New York to LA, that are dedicated to you. You can guarantee, for example, on a T1 line, a 1.5 megabits per second. Since it's dedicated, of course, it's secured. No one will be able to use it. And because it's leased, this is the most expensive way of doing it. No one really does that. Most likely what you're going to be doing is you're going to have a point-to-point connection, maybe a T1 line or something similar to that, to your ISP, the switch at the ISP, and from there you can go into the cloud, into the internet. So you get that dedicated line to your ISP, and from your ISP beyond that, there's pretty much you can get gigabit if you wanted to. There's hub and spokes. Hub and spokes means you can have everybody connects to your um, main office, the central office. So this will be the hub, the main office, the main headquarters, and all the other sites will connect to you. You pretty much can do that through the web. Uh, the internet is what I'm saying. Full mesh is you can have all the different sites. There's no one through site. They can all interconnect with each other at any time. If one site goes down, the other three can still communicate. Here, since you are all connected to the hub, the main office, the hub could be a central point of failure because that's probably where all the servers are and all your resources that you need to connect to. Here, you probably, if one goes down, you can still have connection to all the three. Or you could do a dual home, provide redundancy, semi-mesh, let's put it that way. You can have a redundancy to eliminate the central point of failure in the hub and spoke. You can have another one as a, sitting idle just in case the central, the headquarter fails, the other one will pick up immediately. All right. So those are the 4 common topology. Again, write those down, the 4 different topologies that I used in the WAN. Um, as business grows, you can have a small office at home. You can set up a small office and you want to connect maybe to the home office or where you have all your resources. So that would be called the SOHO, small office, home office. SOHO, if you ever see that, that's what that means. That means from your home, you can connect to your uh, to your headquarters where all the servers are and all your resources. You can have a campus network, like if you come to work, and you can have your VLANs interconnected and you're all connected. We set that in class. For example, you have one VLAN, the marketing, the engineering, you can have the accounting, and they all can communicate with each other. Or maybe it could be a university campus that has all the different VLANs with each other. You can have branch networks, um, networks that are all over the place. It could be, all over the world, not necessarily all over the country too. And you can have a distributed network, where you can use VPNs. You can have teleworkers. You can have branch offices. You can have home offices. Branch offices are all connecting to this central office where everybody wants to connect. So this is probably growing more and more because you can use the internet to connect all of these different types of businesses and remote users. You, of course, setting up a VPN to connect. Okay, now I want you to write each one of those down because I want to make sure you understand these terms. So when we talk about them, either in class or somebody mentions any of these terminologies, you should be familiar with them. The CPE, the customer premises equipment, anything that's inside the building that owned by the organization, that's the CPE, the central point, I'm not central, customer premises equipment, such as your routers, your switches, all of your devices. So if anything goes wrong with the CPEs, they fail, it's the responsibility of the business, the organization, they'll take care of it. Anything that goes beyond the local loop right here, the demarc, they call it, the demarcation point. So the demarcation point is where the responsibility of the organization ends and the responsibility of your service provider begins. The local loop is the connection between you, where the demarc point is, to the central point, to the central office switch. This is where you may want to get a dedicated line, a T1 line connection. And then from there, your service provider will throw you on the WAN, either the public WAN, the internet, or private WAN to connect to. Okay, a DCE device is the one that, for example, the central office will set up a clock rate to synchronize with a DTE device to tell you how fast data is going to be transmitted and received. A data communication equipment is the one that sets up the synchronization between the two links, because when you have two directly connected devices, one of them has to be the DCE and the other one has to be the DTE. The DTE is the device that the data terminal equipment is the one that's going to be on the other side. The DCE is the one that sets up the clock rate that says, for example, hey, I want to transmit at 64,000 bits per second. That's how many data I'm going to be sending out and receiving. And the DTE device on the other end is going to accept that. So the DCE is the one that provides the interface connects to a communication link. If you do not set a clock rate on the DCE end, for example, you won't be able to have a communication with them. So the DCE device right here, even though it might be inside the premises, it's really set by the central office. The DTE device is your router. So this guy says the clock rate, and then the DTE will say, okay, I accept. The demarcation point, again, is the point where the responsibility of the organization ends and the responsibility of the service provider begins. The local loop is sometimes referred to as the last mile. That's the connection from your from the demarc point, the junction box, all the way to the central office. Central office is where the connections that connects you to the WAN. All right. And the total network is all the cabling equipment inside the WAN provider. All right, moving on. WAN devices. The WAN devices, you have a dial-up modem. That is the one, for example, if you do not have any connections and you only cable or DSL or Fios or whatever type of these fast broadband connections, you probably still have the plain old telephone system, the POTS. So to be able to connect to the internet for WAN, you're going to use your old telephone wires. But the telephone wires are that they connect to analog devices. And if you connect your computer and your computer is a digital device and you start sending digital data, those analog devices that connects the old telephone wires won't be able to recognize that digital data. So what you need to do is you need to place a modem, a dial-up modem. MOD stands for modulating, which means it's going to modulate, convert your digital data into analog so it can fool these switches into thinking that this is an analog signal. And on the other end, when you're receiving the data, you demodulate. Demodulate means that's what the DEM is for. You convert the analog back to digital. So the modem allows you to convert, modulate the digital data into analog and demodulate the data back into digital. The access server, okay, is the one that for like the radius server, if you ever had a dial-up, you would go to the access server and they will set you up, authenticate you, you dial up, and then they'll set up a circuit connection for you, right? Your broadband modem, you may have a cable modem or a DSL modem to allow connection to the internet or to the WAN. The CSU DSU device is the one for example, on your router. That's where your DCE is and DTE. Like this is could be the smart jack that connects you to your WAN switch. And the WAN switch is allowed to connect, connects from your T1 line to your WAN switch. This is a T1 connection, allows you to get on the internet. Your router is the third layer device that usually found on the premises of the organization, the CPE, that allows layer 3 or the interconnection of LANs together. Excuse me. And the core layer, multi-layer switch, layer 3 switches, that's what these are, will able to move data according to either layer 2 or layer 3 packets. So it supports both. All right. The WAN operations. So you can either have a switched network or packets network. Switched network means that you're going to have a dedicated line. If you don't have a dedicated line that is 24/7 open for you because it's extremely expensive, what you could do is you could dial up to an access server and the access server will create a dedicated connection, a circuit, dedicated circuit for you to your destination. So your data will always use that wire and no one else will be using it. But the problem with dial-up is the connection, the slow. It's in kilobits per second, but you have a dedicated connection. Once that dedicated connection is done, that circuit is done, then somebody else can use it. That's what circuit switching is, but it's extremely slow. Dial-up and ISDN uses this. Packet switching works like the internet. You can share the wires with someone else, and according to a label that's stamped on the packet, you'll be routed depending on where your destination is, and you can get destination. This is the most efficient way of using all the wires. But if there's a lot of traffic, you're going to slow down, and that might be an issue. But it's a lot less expensive with packet switched networks. Okay, so I want you to also write this down. If you can draw this is very important. The different types of WAN connections. So if you go to a client and your client cell tells you, listen, I have 2 LANs that are in different geographic area and I want to be able to connect these 2 different LANs. So you go in and you say, all right, you got 2 choices. You can either go privately or you can go through the public internet. The least expensive way, which over 80% of the organizations do, is they go with the internet. And if you go through the internet, you have to set up a VPN, which is very easy to do. A VPN offers you a connection over the internet. It's secured, and and if you have the bandwidth, you're all good to go. The only problem with the VPN is you're still prone to denial of service attacks. If the network fails, if the internet fails for whatever reason, or if somebody notices, or somebody can jam your servers or your VPN appliance from connecting you, then you may have trouble connecting, uh, you know, connecting to your other site. But it's the least expensive way. And but security, that's not an issue. Your VPN tunnels and the encryption methods are so powerful, no one will be able to really decipher what the data is. Now, if your data is so sensitive and you want guaranteed connection, you probably want to go private. With private, you have two choices. Either you can do dedicated, which is the most expensive way, have dedicated wires to your destination, or you can go switched, either circuit switching or packet switching. The most widely used is the Metro Ethernet, MPLS. Frame relay and ATM are really dying out. MPLS is the top of a VPN that allows you to connect pretty quick without have to reaching in and grabbing the packet. They actually take the packet and put some labels on it on the frame itself and move the data very quickly. Metro Ethernet is growing, is probably the fastest growing with MPLS really when it comes to private WAN connection. Circuit switching, the old PSTN and the ISDN, they don't really deploy these anymore, but they're still out there. And because you're only going to pay for when you are using them, so might as well just leave them there for backup. So if my Metro Ethernet or my VPN fails, I can always have a backup using the ISDN. So there's probably a chance when you're out there on the job that you may still have to support an ISDN or even an old dial-up connection. All right, so dial-up, the advantages, of course, is it's the least expensive way, and probably there's a very good chance you may not have to deal with this, right? Anyway, ISDN, the Integrated Service Digital Network. There are two different types. There is the bearer rate interface and the primary rate interface. The BRI give you 264 kilobits per second, and the D channel, the two bearer channel and the D channel. The one you can use one for data. When I remember in the early 1990s, because dial-up was an issue when you're getting on the internet, you can't use your phone, and if you're using your phone, you can't get on the internet, and it was analog, and the connection was very, very slow. So ISDN came around and says, all right, what we're going to do, we're going to dedicate one 64 kilobit for data and another one for voice. And the D channel, which is 16 kilobits, is going to really make sure it can differentiate which one's voice and which one's for data. And that's where the SOHO, the small office, home office, kicked in. So you can actually sit home now and be able to communicate with your phone and sitting on your computer doing all your work. Right? You don't have to go to work anymore. You can stay home. But 64 bits in the early 1990s was not bad at all. But then they wanted more bandwidth, so what they said, okay, you know what? I'm going to get my telephone from a separate service provider, but I want the ISDN connection, and since I'm not going to be using voice here, I want everything for data. So what they did is they tied up the two bare channels and the delta channel, the D channel, together. So you were able to get everything for data up to 144 kilobits per second. Okay, then the primary came. The primary rate interface, ISDN, says, okay, I'm going to give you 23 channels that you can use for voice and data, and one D channel for to really differentiate between voice and data. Now, if you do not want to use any of these for data, you can tie all 24 channels for data. I'm sorry, if you don't want to use them for voice. So tying all 24 channels for data, and if each channel can offer you 64 kilobits, 24 times 64, that's what a T1 line. A T1 line is an ISDN primary rate interface service. That's what it is. T3 line is taking 28 T1s together. That gives you approximately 45 megabits per second. All right, so if you go and call a service provider and you tell them I want a T1 line, what you're asking for is an ISDN primary rate interface service. In Europe, they tie 30 of them. You get about 2 megabits per second. But that's directly connected, right? Dedicated connection. Frame relay. Frame relay is an older technology that allows you to use on the frames itself. What they do is they set up a data link connection identifiers on the data, something similar. You can think of it like the internet labeling, and you can share the wires. So when you take the frame and you, depending on where you're going, I'll give you a label, and when you are passed from one side to the other, I look at the label, and then I find out, and then I change the label, the DELC number, and then I place it on, give you a different DELC, and you connect. So each connection is called a permanent virtual circuit, PVCs, and each PVC has its own DELC. So when you come in with a specific data link connection identifier, I call them DELCs, and I look at the DELC depending on and your destination where you're going. I'll remove that DELC number, put a different DELC on, and you get on another wire. It's like taking a bus, taking bus 15 to get to here, then you get out of bus 15. But number 15, bus is the frame. You get out of that bus. Actually, you don't get out. You just change the label, and you take bus 50 to get to your destination. Or something like that, right? That's what frame relay is. You're relaying the frame from one hop, from one router or one frame relay switch to another till you get to destination. You're taking different, and your DELC number change. The good thing about frame relay is you don't have to pull the packet out of the frame. You leave the packet inside the frame. You're just looking at because all the frame relay switches, they already have these labels, and depending on when you come in with what label that's stamped on the frame, that's the DELC number, you'll be switched or relayed, quote unquote, to the other frame relay switch. All right, then you got the ATMs. The ATM is the asynchronous transfer mode. It uses cells, and what it does is it breaks up the data into very small cells, 53 bytes. 5 bytes is really for the control, and about 48 bits is for the data. Since you have very small amount of cells that are going to leave the router, and almost any device across the network will be able to handle 53 bytes. And if they can't, they'll pass it to somebody else. So no matter how busy they are, 53 cells is very easy to process. So data will be moving very, very quickly, no matter how congested the network is. So that's why ATM is used for real-time video and voice in the old days, right? Please write that down. And write that, well, just what ATM, because this may come up. And by the way, how do you do that? You need to have ATM NICs and ATM switches to set you up for that. Simple as that. They can go for you up to 600 megabits per second. The Ethernet WAN is popular now because you can get gigabits. As long as you are within a city limit in a metro area, you'll be able to use Ethernet, and that's what's really now replacing frame relays and ATM networks because of how fast it is in comparison to the other two connections. Frame relay is really, really slow, and that's really being pushed out the door. Ethernet is probably, and we're all familiar with Ethernet, you can get gigabit per second. And since the distance is not that bad, and you can have, as long as we're not talking about in a completely far away connection, but you are within a metropolitan area network, Ethernet WAN will be the best way to go. But Then you got the MPLS, and as I said earlier, MPLS is really similar to frame relay, but it has labels on the frames, and so actually it takes your actual packet, puts it into an MPLS frame, and stamps that frame into, and it has labels on it, and you're just moving the frames around. Right? Then we were looking at the labels and we're moving the frames around. So it's really a VPN MPLS, the multi-protocol label switching, but it's not secured. It's just to move data very, very quickly in here without having to reach inside the packet. You know, if you have a regular router, the regular router takes the data, takes the frame, pulls the packet out, has to inspect the IP addresses, re-encapsulate it into another frame, and sends it out. That creates a lot of delay. So what MPLS does, it just looks at the label and moves the data according to what the label that's on there, right? Much faster. The packet stays inside, of course. Write that down, by the way. What is MPLS? Just in case you are asked. All right, so that will be something that you want to write down for your notes that you're going to submit for homework. The VSAT, the very small aperture terminal, that's for satellite WAN connection. Then you have the DSL. DSL will use your old plain old telephone system to send you digital data and voice. So when you have your DSL modem that connects to your DSL multiplexer, the DSLAM, so you'll have voice and data. And what they do is they send you microfilters at home, so you can set the DSL, and the microfilters go to the connection before the phone because they want to be able to filter out the data and only let the voice go to the phone. But you don't point the filters here to connect to your PC, then you'll lose your data. That's what a lot of people do when they send them these filters. Okay. But now DSL in the Northeast has been replaced mostly by FiOS. And if FiOS is not available in your area, so your only choice is either DSL or cable. Since you have cable TV connection to your home, so what they did is they dedicated a specific amount of frequencies within the cable just for data, and then the rest of the frequencies will be used for the rest of the bandwidth. So if you have a bandwidth of 100 meg coming to your home, all that bandwidth was used for video. So now they dedicate, for example, let's say 30% of it for data, and then the rest will be for video. So that's probably much faster. Not probably. You can get voice, data, and video through cable because you can over a little bit close to 100 megabits per second. Okay, and then you have the wireless. There is the municipal Wi-Fi. There is the WiMAX. So many cities have their municipal Wi-Fi's connection, including, you may think of the libraries and even local parks, for example. The WiMAX, the Worldwide Interoperability for Microwave Access, is a new technologies. If you can have, for example, these wireless connections, you can have voice, video, and data no matter where you are. The good thing about the 802.116 WiMAX is it envisions that all networks are going to be wireless, and all of these wireless network WiMAX will interconnect them with each other ultimately, and the WiMAX connects to the internet. So in other words, no matter where you travel across the country, you can still have your voice, video, and data with you connecting to the WiMAX. But the problem with WiMAX is it's a little bit expensive, and you have to have these expensive antennas, even at your home, connecting to these big WiMAX connection. Ultimately, they'll go on the wire to connect to a wired network. But since they are a little bit more expensive, the 4G and the upcoming 5G competes with them. So that's why they have not really gain any tractions. Then you got the satellite internet. All right, typically used by rurals, the people that don't have any connections to even dial up. So they might want it, but that's expensive, of course. All right, then you have the 4G, 3G, 4G, the long-term evolution, the light 4G, the 5G that's coming um, for mobile users. So everybody has that, and you probably don't need the. That's why satellite is not used as much, and that is why the Wi Max also is not used as much because even the upcoming 5G is going to really blow everything out of the water. So you're going to have very nice high-speed connections with it, even the LTEs. But it's mainly used for mobile users. You can use it on your laptops and take that wherever you want to. But the connection is not, not that great if you use it for data. But for voice, of course, it's wonderful. All right, moving on. Then you have the VPNs. If you want, like we said earlier, you want to connect later on this semester, we'll be able to set up a site-to-site VPN using the Cisco proprietary GRE protocol. But it's not a secured VPN. We'll be able to talk about in another class with the Cisco security class where we set up a site-to-site secured VPN using IP security. So again, VPN allows you to send data as a from one LAN to another using the internet. So you set up a tunnel, and if you want a secured VPN, then you encrypt the data inside the tunnel when you are passing it. All right. When it comes to remote access, then you have a user that he's the one who initiates the VPN connection. All right. But when you have site to site, and let's say you're sitting right here, you don't even know that you're getting on the internet. It's your router that sets up the VPN for you for site to site. With the remote access VPN, again, it's the user. Like when you type in, and anytime you type in HTTPS connection, you are initiating a VPN to that server. All right, so please write down the benefits of setting up a VPN and what a VPN is and the two different types. So write that down. Good to know. All right, so which type of WAN service you want? So you have to be able to answer all of these different questions. If you are in organizations, what's the purpose of the WAN? Why do I need it? What's the geographic scope? How far is my branches that I want to connect them with each other? How fast, what is my traffic requirement? How fast do I want to pass data? Is it guaranteed? Is it secured? All of that. You got to be, once you answer all of these questions, then you can pick one of those different services that really fits your specifications. All right, so that ends chapter 1. And until chapter 2, keep up the good work, guys. Make sure you submit whatever you're asked to write down for homework. All right, until then, keep up the good work.